Good day, grade 12 learners. Welcome to today's mathematics lesson. My name is Analytical. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center. Our lesson for today is revision for paper 2, and we're going to focus on analytical geometry, which has between 37 and 43 marks in our paper. Please have somewhere to write on because we are going to do a lot of writing today. Now, just as a way of reminding each other, we have between 37 and 43 marks for analytical geometry in paper 2, and we have 4 topics. We have revised statistics. So today we are revising this one. These two, we will revise them on the day before we write our paper 2. So trigonometry and Euclidean geometry, we will revise them just before we write paper 2. Now, we know the structure of our paper and we must be setting our targets. So for us to get a 45% pass, we must get a minimum of 18 marks for analytical geometry. For us to get a bachelor pass, we must get a minimum of 25. Now, moving forward, here we have our information page. Please, let's remember to always refer to our formula page. And we use these a lot for paper 2. Yes, for our analytical geometry, we use a lot of these. And then we'll move on now. For trigonometry, we use most of these ones in the given page. Now, our objectives for today is to revise analytical geometry learned from grade 10 and 11. We also need to determine the equation of a circle with center at the origin and at any point labeled AB in the Cartesian plane. We also have to determine the equation of a circle with center AB and the equation not given in standard form. Remember, we can be given the equation of a circle as ax squared plus by squared plus cx plus dy plus e equal to 0. We have to move it to the standard circle equation for us to determine the coordinates of the center as well as the radius. Now, we also have to determine the equation of a tangent to a circle and the length of a tangent to a circle. We also have to determine whether a point lies inside or outside a circle, or it's on the circumference of a circle. Now, we also have to determine the relationship between circles, whether the circles intersect internally, externally, or do not intersect. Now, we have to analyze the relationship between a circle and a line, whether the line is a tangent, it's a secant, or it does not intersect the circle. We refer to the CAPS document on page 47 as well as the examination guidelines for grade 12 for 2021 on page 8. Now, our pre-knowledge, we know how to use the distance formula to perform calculations. We know how to use the midpoint of a line segment, the gradient of a line. We also know gradients of parallel lines, perpendicular lines, as well as collinear points. We also know angle of inclination and how to calculate it. The equation of a straight line. We know how to determine the equation of a straight line as well as to read information from the equation of a straight line. Now, these are concepts that we have looked at before, so just as a quick reminder, if we have a line segment AB, we are able to determine the distance between the 2 points. We will have the distance formula as in change in x squared plus change in y squared. It will give us the distance there. And I hope you are aware that this comes from theorem of Pythagoras. If we are to determine the hypotenuse here, so the x value at this point will be x at b, xb, and the y value here will be y at a. So we have x at b and y. Those are the coordinates of that point, and that is the distance. That is the distance. And when we apply theorem of Pythagoras, we are able to get the length of AB there. This is a right angle. Now, we also know the midpoint. The midpoint is half the distance between the two endpoints. Now you sum the x at A plus x at B, we divide that by 2. Y at A plus y at B, we divide that by 2. It gives us our coordinates of the midpoint. Moving forward, we also look at the gradient of a line, which is also known as a slope or the inclination of a line. We are able to determine gradient by using change in y over change in x, and that will give us the gradient of that particular line. We also know that gradient, we use it to determine whether the lines are parallel or not. So if lines are parallel, we know that the gradients will be equal. Or if we have equal gradients for two different lines, it means those two lines are parallel. We also deal with perpendicular lines, the lines that intersect at right angles. So we use the gradient. If the product of the gradients for the two line segments gives us -1, it means the two lines are perpendicular to each other, or the angle between the two lines is 90 degrees. Now, we also look at the equation of a straight line, which can be given as y minus y1 is equal to the gradient times x minus x1, and that will give us another form, which is y is equal to mx plus c, and we use any of those to help us determine the equation of a line, or to write the equation in standard form, the equation of a straight line. So when we look at the angle of inclination, we have two conditions. When our gradient is positive, our angle of inclination is acute. Remember, the angle of inclination is the angle that a line makes with the positive x-axis. Now, so it's between the x-axis and the line. This angle that we have here, it's what we call the angle of inclination. Now, if the gradient is positive, it will be acute, and if the gradient is negative, it is going to be obtuse. It's more than 90 degrees, but less than 180 degrees. That's our angle of inclination. Then we also talk about collinear points. Collinear points, these are points that lie on the same straight line, and the property that we use there is the gradient. If points are collinear, the gradient between any of the 2 points should be equal. So the gradient of AB must be equal to the gradient of BC, which must be equal to the gradient of AC there. That's how we determine whether points are collinear or not. Now, we also have a circle. We know that a circle can have its center at the origin, and the equation of that circle is given by x squared plus y squared is equal to r squared. Or we can have the center of the circle at any point in our Cartesian plane, and the equation of that circle is given by x minus a squared plus y minus b squared is equal to r squared. Now, there is also a relationship between a circle and a line. Now, a line can intersect the circle at two different points, and we call that one a secant. So when we solve simultaneously, we must get two valid x values and y values there as points of intersection. And then when we get a solution, when we have the equation of a circle and the equation of a line, and we only have one solution, it means that line is a tangent. It intersects the circle at only one point. And then we have, if there is no intersection, it means when you solve the equation simultaneously, we will not get a real solution because there is no valid point where there is a common x value or y value there. So we say the line does not intersect the circle if we are given that condition. Now, we also look at circles that touch. We know that circles can touch externally. You can demonstrate this using your coins. You have your 5 rand and a 20-cent coin. You are able to see that the circles are not equal in size. The 5 rand is bigger than the 2 rand, but they can intersect externally, where we are saying the radius of the smaller circle plus the radius of the bigger circle is equal to the distance between the two centers of the circles. We also have where one touches the other one internally, where we are saying the distance is equal to the bigger radius minus the smaller radius. They have to be equal. The distance, bigger radius minus smaller radius, they have to be exactly the same. Then it means one is touching the other circle internally. And then we have the condition where the circles intersect each other at two different points, and our diagram would look like that. And we are saying the distance there should be between the bigger radius minus the smaller radius and bigger radius plus the smaller radius. So the distance that you calculate, it means it's not exactly equal to radius small plus radius big, but it will give us the distance in between the two extremes. Now we will have it as such. And then we have circles that do not intersect. The distance is bigger than the bigger radius plus the smaller radius. The circles do not touch. So we are able to see those conditions, and the examiners like these questions. We also have circles that is inscribed inside the other circle, or circles that share a common center. Those are called concentric circles. You will find out that the distance between the two centers is less than the bigger radius minus the smaller radius. So one circle is inside the other, but it's not touching. Remember, when it's touching, the distance is exactly equal to the bigger radius minus the smaller radius. So we have those conditions. Now, I will ask us to answer this question. I will give ourselves 14 minutes to answer 3.1 up to 3.5. We'll mark it, then we'll move on. I'll give you time to answer 3.6 and 3.7. Welcome back. I hope you managed to answer the questions from 3.1 up to 3.5. Anything with a diagram, for me, it is a given because all the information and all the answers are in front of us. We read the information that is given there. In the diagram, P has coordinates -12 and -9 and 12. Q has coordinates 9 and 9, and R are the vertices of triangle PQR. We are able to see triangle PQR there. M is the midpoint of QR. We know that if it is the midpoint, it means MR is equal to QR. Do this on your diagram so that you are able to see what can help you there. Now, from there, we are told that N with coordinates A and B is a point on PM. So you are able to conclude that P, N, and M are collinear points because they lie on the same straight line. And N is in the second quadrant. We are able to see that the equation of QR is given by 2y. So I also have the equation of QR there, which is 2y minus 3x plus 9 is equal to 0. We can write it even in standard form, y is equal to mx plus c. And then the angle of inclination of QR is theta. So once we have the gradient of QR, we are able to determine theta there. Now, the first question, we are supposed to calculate the coordinates of M, the x-intercept of line PM. Now, you are able to see that that point is common because it is both on QR as well as on PM. So how do we get the coordinates? We are given the equation of QR, therefore we are able to get the equation there. So we are going to use that, and we know that for us to have M will have coordinates. We are able to deduce that it's along the x-axis, which means our y value is going to be 0. We substitute 0 there and we get our x as 3, which means the coordinates of M are 3 and 0, and that's how we get for x and y, we get our 2 marks there. The equation of PM in the form y is equal to mx plus c. So we have the coordinates of P and the coordinates of M as 3 and 0. Please add it to your diagram so that you are able to see. We find the gradient of PM and we should get it as -1. We substitute into the equation of a straight line the gradient and a point. So we are going to use the coordinates of point P or the coordinates of point M. It's up to you. And we will get our c as +3, and our equation becomes y is equal to -x plus 3. So we find the gradient of PM, we substitute the coordinates and the gradient of a point, we get our equation as that. That's how we get our 4 marks. We have to calculate the size of angle theta. For us to calculate the size of angle theta, we must find the gradient of QR first. Now, how do we find the gradient of QR? We can either use the coordinates of M and Q, or we can use the equation. I'll suggest you use the equation so that if, for example, you made a mistake on the coordinates of M, it will follow that the gradient of MQ will not be correct if the coordinates are not the correct ones. But if you use the equation, there's no way you can go wrong as long as you are able to change the subject and write it in the form y is equal to mx plus c. So our equation given by 2y is equal to 3x minus 9. We divide both sides by 2, and this will give us y is equal to 3 over 2x minus 9 over 2. So from there, we are able to deduce that the gradient will be 3 over 2, and the tan of the gradient gives us The tan of the angle of inclination gives us the gradient, so we'll get our angle of inclination as 56.31. So for gradient as well as for the angle, we get our 2 marks. We have to show that B is equal to 3 minus A if P, N, and M are collinear points. Remember what we said. Collinear points means the points lie on the same straight line. So we found the equation of our line PM as y is equal to negative x plus 3. So that point, when our x is A, our y is B, we just substitute into that equation and we are able to get B as negative A plus 3. When rearranged, this is the same as 3 minus A. So you'll get a mark for substituting the coordinates of N into the equation of PM. We get our 1 mark. So far, so good. We should be having 9 marks now. We move on to 3.5. We are supposed to determine the value of A and B if NQ is equal to 5 root 5 units. So to help us answer that question, we now have this NQ is 5 root 5 units. We are going to use the distance formula to find the length of NQ because we are given the length of NQ, but we do not have the values of A and B. So we use the coordinates of Q and N, which will give us A minus 9 plus B minus 9. But already we have found the value of B as 3 minus A. We substitute into the equation so that we only have one variable and it's easy for us to solve. We will get 2a squared minus 6a minus 8 is equal to 0 in standard form. We substituted for a, and then from there we can use factorization. We choose the correct value of A because it's in the second quadrant, it can't be 4. So this one is not applicable now. And that will give us our B as 4. So the value of A as well as the value of B, we get our 5 marks there. Now we have 3.6 and 3.7. We are supposed to determine the equation of a circle, center O, at the origin and passing through the point R, and the acute angle between the lines QR and the equation of y is equal to mx plus 4. If we are given that the angle is 45 degrees between the line QR and the equation of that line. We have to determine the possible values of m, which is our gradient, and I'm going to give you 6 minutes to do this. Welcome back. I hope you were able to solve 3.6 and 3.7. Now, to make our life easy, now you can just, this is the center with coordinates 0 and 0. So this circle is not given, but we are told that it passes through point R. So that's our circle that passes through point R. So it means OR becomes our radius there. But this is not given, so I can just make my radius to be a dotted line like that. What do we need? We know that the coordinates of the center are 0 and 0, so we need the coordinates of one point. And we know that MR is equal to MQ. We have the coordinates of M here as 3 and 0, and that is what we are going to use. The x-coordinate at R plus the x-coordinate at Q must be equal to the x-coordinate at the center. The y-coordinate at R plus the y-coordinate at Q divided by 2 must be equal to the y-coordinate at the center, which is 0. So this will help us to form those two equations. We solve them and we'll get the coordinates of R as -3 and -9. From there on, we use the equation of the circle, x squared plus y squared is equal to r squared. Then we substitute the coordinates of the point, and we should get our r squared as 90. Then we substitute, we get our fourth mark there. The acute angle between the lines QR and the equation y is equal to mx plus 4 is 45 degrees. Determine the possible values of m. M becomes the gradient of the line. Now, if we can move quickly there, we let beta be the angle of inclination of the line. Now, y is equal to mx plus 4, and we are saying the angle between QR and the blue line is 45 degrees. That is the angle there. But remember, this blue line will also intersect the x-axis, and that will give us our angle beta there. And we are saying, if we check, we formed a triangle there, even if we do not have the vertices of that triangle, but you are able to see because we have got the y-intercept as 0 and +4 there. So we are using the fact that this angle plus that one equals to our exterior angle. That's what we are using. So we should get the size of angle beta, and we should get our beta as 11,31, and the gradient becomes the tan of our angle of inclination, which is 11,31, and we should get our gradient as 0,2. So for getting our beta as 11,31 and using our angle of inclination to determine the gradient, that is going to help us. The second condition, we can have our line as having a negative gradient. It intersects the line QR at 45 degrees there, and I hope you are able to see that we can form a triangle there. And we are saying this angle of inclination that we calculated, it's a vertical opposite angle to this interior angle of this red triangle. And we know that this angle plus that one should give us the size of our angle beta there. And we should get our angle beta as 101,31 degrees. And we take our calculators, then we use the angle of inclination to give us the gradient as -5. Now, so those are the possible values. So as you can see, drawing a diagram makes your life easy and you are able to see what is actually happening there. We move on now to the next activity, where we have the question from the Free State Prelim paper. I will give you 13 minutes to answer 4.1 up to 4.3. Welcome back. I hope you were able to solve this question. We have a circle center M that touches the x-axis at C and the y-axis at B. Those are the points. And a second circle with equation x squared plus y squared plus x minus 3y plus 2 is equal to 0 passes through A and M and intersects circle M at A and B. So now this other circle, we are not given the coordinates of the center. In this case, I will call them N, the coordinates of the circle, of the center of the smaller circle. The equation of the common code AB is given by y is equal to negative x plus 1. Now we have to determine the coordinates of the center and the radius of the circle which passes through point B, M, and A. So we want the coordinates of the center of the circle, center N. We also have to calculate the coordinates of A, but let's start by determining the coordinates of the center of the smaller circle. How do we do it? Now, we use the method of completing the square, and we know that we add half the coefficient of x and we square it. So the coefficient here is 1, half of 1, it's a half, and we square that, half of y. So there the coefficient is negative 3, so it's half of negative 3, which gives us negative 3 over 2. We add it and square it. What we have done on the left, we also add them on the right, and this will give the and that, and it will give us x plus half squared plus y minus 3 over 2 squared is equal to half. So now we have written this in standard form. So either this mark will be given for the left hand side and the 1 mark for the right hand side. From there on, we are able to deduce the coordinates of the center from x minus a squared plus y minus b squared is equal to r squared. So that's how we will get that. So the coordinates of the center will be negative half and 3 over 2, and the radius becomes the square root of half, and that will give us the radius. We get our 4 marks. The next question, we have to calculate the coordinates of A. Now, if you check A, we said we are given the equation of the common chord AB. So AB becomes a secant because it intersects this circle at 2 different points. How do we get the coordinates using that? So we have the equation of a line and the equation of a circle. We solve them simultaneously, and we should get our equation in standard form as 2x squared plus 2x is equal to 0. So where there is y, we'll substitute with negative x plus 1, and then this will give our x value as 0 or negative 1. So you are able to see that because B is the y-intercept, so it means the coordinates at B here are going to be 0 and positive 1. And the coordinates at point A will be negative 1. We substitute into the equation, and that will give the coordinates of A as negative 1 and 2. So substitution, standard form, both values of x and rejecting that x, we will give us the 5 marks there. We move on to the 4.3. We have to show that the equation of the circle center M is given by x squared plus y squared plus 2x minus 2y plus 1 equal to 0. Now, we are able to see this by, we have the equation of the smaller circle, and we have determined the coordinates of the center there of n. We determined it earlier on. Now we have to determine the coordinates of M. And for us to determine the coordinates of M, you are able to see that M lies on the circumference of the smaller circle. So how do we do it? We have the y-intercept is 0 and 1, which means the y value at point M is going to be 1. We have to solve for x. So where there is y, we will put 1 and we'll get our radius squared as 1. And from there on, we are able to see that the coordinates of point M are going to be 1 and 1. And that gives us the equation as x plus 1 squared plus y minus 1 squared is equal to 1. From there on, we are able now to expand. And when we expand, we'll get x squared plus 2x plus 1 plus y squared minus 2y plus 1 then is equal to 1. Then we transpose and then we'll get the equation as such. So getting the coordinates, the coordinates of the center, substituting to get our r, and then expanding the left hand side and then simplifying, and that will give us the final answer there. Now I will give us 6 minutes to answer 4.41 and 4.42. Welcome back. Now, the straight line with the equation y is equal to negative x plus k is a tangent to the circle with center M. Now, do we have the equation of the tangent? Yes. Do we have the value of k? No. We have to show that the equation can be written in the form. How do we write the equation of a tangent? Now, we are going to do the following. Now, we have the equation of the tangent, we have the equation of the circle. Where there is y, we are going to substitute with negative x plus k. A lot of algebra, we need to practice our algebra thoroughly, and this will now give us our equation as x squared plus x squared minus 2kx plus k squared plus 2x plus 2x minus 2k plus 1. Now, when we collect like terms, we will get 2x squared from x squared plus x squared, and then we have negative 2kx, and we also have our 2x plus 2x, which gives us the 4x. These are sharing the same variable, they are like terms, and then we have the constant, which is that one, and we will get our equation as 2x squared plus 4 minus 2kx plus k squared plus minus 2k plus 1. So we substitute, we simplify, then we are able to collect like terms to give us the equation that we need. So we get our 3 marks. The next part, we are supposed to calculate the numerical values of k. Now, for us to get the numerical values of k, we are going to use our nature of roots, in which case our delta, if you check our equation, sorry about that. Now, if you check our equation, it is given by 2x squared plus 4 minus 2kx plus k squared plus minus 2k plus 1 is equal to 0. Now, this takes the form ax squared plus bx plus c. So from there, we have to evaluate our delta, and because we want the numerical values of k, it means our delta must be greater than or equal to 0. Because it's a tangent, there's only one intersection, so it's a repeated root. So from there on, we are going to use delta is equal to b squared minus 4ac. Our a is 2, our b is 4 minus 2k, so we'll have 4 minus 2k, we square that, plus, sorry, minus 4. Our a is 2, we have k squared minus 2k plus 1. When we simplify this, it will give our delta as 16 minus 16k plus 4k squared minus, this will give us minus, if we check, negative 4 times 2 will give us negative 8 times that, we get negative 8k squared. Negative 8 times negative 2 will give us 16k. Negative 8 times positive 1 will give us negative 8. When we simplify this, remember, our delta will be equal to 0 because we have a repeated root. So 16 minus 8, so this will give us 8. Negative 16k plus 16k will give us 0. 4k squared minus 8k squared will give us negative 4k squared, which means our 4k squared is equal to 8. We divide both sides by 4. We get k squared is equal to 2. which means our k is equal to plus or minus the square root of 2. So those are the values of k. So our k can be negative square root of 2, or our k can be equal to the positive square root of 2. So those are the possible values of k. Now, you can see that this involves a lot of paper one, so we must be able to use those conditions that I mentioned about the lines intersecting with a circle or not touching. So that's where we apply that concept, and you are able to see that 5 marks is a lot of marks, and we need to know how to do this. Let's practice these questions. So I'll ask you to do this question at home, and you are able to get the memo from our website from the June 2023 paper 2 question 4. Let's practice these questions, and we use the memos to mark. You answer the question first, and then you refer to the memo to mark yourself after you have answered. And let's continue to time ourselves. Time management is very important. Now I'll move forward very fast. Let's move forward. We are going to the end. You are able to see how we got the memo there, how we are going to get the marks, but you'll do it later on. So in summary, we are saying it is important to analyze the diagram of the given information and to identify what can be used. You saw add information to your diagram. So diagrams are not drawn to scale, so we do not measure. We must use the diagram effectively. Add information to your diagram, label correctly, and identify the angles and the sides that you can use. Also, write the given information on the diagram as I have mentioned. As you get answers, add them to the diagram. It will make life easier for you to get the next thing. We draw additional lines so that we get a clear picture. You saw with the one where we're supposed to find the gradient of the lines that are intersecting a particular line. The diagram makes it easy because you are able to see what you can use to help you get what you don't have. Please let's revise the properties of triangles and quadrilaterals. As you see that some of these questions refer to the work that we have done in the earlier grades. Let's practice. Know the formulas for areas and perimeters of the basic shapes, because we may be asked to find the area of a triangle, the area of a rectangle. We must know the formula for us to answer such questions. We are encouraged to use color so that we are able to see what we are dealing with. And we refrain from making assumptions. It must be given. And please let us always read the information that is given before the question so that we are able to answer correctly. With that being said, I thank you. Let's continue to practice. We will see you before we write paper 1, but we continue to practice. Let's practice both papers. Give yourself time. At least do a question a day. If you are doing sequences and series, answer the sequences and series. Also do one question maybe in paper 2 so that we keep these topics fresh with us. Theorems, we practice them every day. Thank you.